Good day. This is video number 2 of our assembly here that we're creating as a top-down design. And today we're going to focus on the wheel, and we'll also create the shoulder bolt, or we may create a separate pin and the appropriate bushings. I think I may have to edit my hole size because the bushing outer diameter is 1 inch. With a forced fit of an FN2. So the idea is that we'll end up having to go back here and adjust the size, because I think I made that 3/4 of an inch in the last design, and we'll update that and we'll move forward. Alright, so that means we have to go back to the angle bracket, and we can double click in the angle bracket, or we are actually still in the angle bracket drawing, because the holes that I created are still listed in the history at the bottom of the screen. The hole listed here for the angle bracket, I can double click or right mouse click and edit that hole feature, and I can update this hole with a diameter from a 0.75 to a 1 inch. And that's all I have to do is just update the 1 inch and choose OK, and now that hole has been updated and we're ready to go. So we need 2 of these angle brackets, and so the easiest way to copy an angle bracket is actually use the Windows copy and paste routine. And so this angle bracket 1, we can right mouse click and choose the copy option, and then we can use the Control V on your keyboard and paste it. Well, when you paste it, it actually pastes it over the exact same position, but it gives you the move command to move this around. So what we're going to do is grab the arrow, and this is going to be the horizontal arrow. We're going to move this out of the way, and we're going to rotate it. So we want to rotate it 180 degrees. Bingo. Once that's done, we'll choose OK, and it's going to create this as a new component. So now we've got angle bracket 1 and an angle bracket 2, 2 separate components in our design. And since we updated the hole size before we copied it, the hole size is automatically updated. And so these 2 are linked in that realm. They are not independent of each other. So the next item that we need to create is the wheel. And that wheel, as you can see, has got a groove in it, and it has an outside profile. And the easiest way to create these is with the rotate capability. Create a profile and then rotate that profile all the way around to create the wheel itself. That's the easiest way to manage that. So we'll end up having to create a new component as part of this. So under the assemble, we can create a new component. Now each one of these is so let me explain it a step back here. We just copied this, and it's not a component, this is a body. Or take it back, it is a component because we copied it as a component. So, excuse me, it is a component. So we're going to create another new component in this design. And the easiest way to do that is to choose new component. It'll come up as a standard component. We got to give it a name. We'll call it wheel. Is it going to be based on the parent, which is the base object, or is it going to be based on a specific body or an object? And it can be based on the original parent, which was the base plate. And that's fine, and we'll choose OK. And so now we have the new wheel component. We need to create it as a sketch. So we'll choose sketch. We have to choose a sketch surface, so we're going to choose the vertical sketch surface here. And then we'll look at it in the front view. Now granted, all the parts and pieces are still in the positions that they started. but you can see that they're kind of ghosted at this point. And again, all we need to do is create the profile, and then we'll generate the shape of our wheel. And so to create the profile, we're going to need to create a design that looks something like this. And it doesn't matter where it happens to be. However, we are going to have to create this. And I'm going to go ahead and create this a little bit higher up so it's out of the way. We're going to draw a horizontal line as our center line, and we'll change this to a center line in just a second. We can actually right mouse click, and it should allow us to make it a normal construction line or a normal center line. And so it's now a center line. We'll create a new line, and this new line we'll start out, and looking at the design of this wheel, we're going to have to start out, create a base, and let's see here. Yeah, it's going to have to come up and then come back in. So it's got an interesting design here. We're going to create it. Up. And then we need to create it coming back in. So we've got the vertical, we come back in a little bit, and then we go vertical, and then we come back out. And then we come up. And then we end up creating the V, and that's about in the center. And we could stop it at this point. And the reason why I might hit the escape key is because we could create another construction line from here, straight down. Choose OK, and then mirror this shape. And I can delete this line. So we could just take this shape and mirror it once we have dimensioned it appropriately. We can go ahead and use the trim command and trim this line back. And now we've got half of our shape. And we don't have everything constrained or dimensioned as of yet. So we know that the inner, let's see here, it says the wheel diameter is 4 inches tall. So from the top to the center point is going to be 2 inches, because the overall wheel would be double that. So let's go ahead and dimension this. From here to here, it's going to be a diameter of 4 inches. So right now it's a diameter of 6 inches. So if I type in 4, what's going to happen? Okay, see where the center line moved? Well, we don't want that to happen, so let's undo that. Okay, we'll leave it at 6 currently. What we're going to do is now add in the hole size, because this is the hole in the object. And let's see here, body hub width is 1.5 inches by 0.75 OD. Groove is 45 and centered. Okay, so the wheel diameter is 4, width is 1, body is 1/2 inch thick, hub width is 1.5 by 0.75 outside diameter. So this would be 0.75. This indicates it's 1/2 inch thick. The hub distance, seems awful thick here. Seems awful thick at 1.5, because what it's telling me is that this to here would be 1.5 inches, or in essence 3 inches, and that seems awful thick. So I'm going to leave it at 2 inches because I think it looks better, and we're actually going to kick this up to 1 inch, which is the size of our other hole. And now that we've got some constraints on this, we could change this. However, there's a couple of things that I want to make sure that are set. Because again, what we're doing is we're dimensioning critical items. This needs to be 1/2 inch. Okay, so this distance needed to be 1/2 inch. The width, body is width is 1 inch. So this is also set up as a 1 inch distance. So right now it's 1.2, so set that up as 1. So that's looking much better. And now we can set this as an overall diameter of 2 inches because all of our critical dimensions are now set. Okay, the dimension for the hole, the dimensions, all the horizontal dimensions, the critical dimensions are set up, and we'll set that at 4 inches. But it's still flip-flopped. And so when things like this happen, when it flip-flops, we can actually grab and move entities if we choose, if we can. Sometimes that happens, and it gives us the ability to grab that and move it. I have to get out of any dimensional environment, and you can see that I can grab and change that and move this position. So you can grab that entity that was thrown out based on that we didn't give it a dimension because it wasn't held fast, or we can undo it, give it a dimension, and then redo it. So this dimension needs to be 1/2 inch because that's what it said, is that all of these objects needed to be 1/2 inch. So let's go ahead and dimension this at 1/2 inch. Seems awful thick, but that's what it's telling us that the values are. Alright, so the next thing we have to do is mirror this. We have to mirror this to the other side. So we're going to mirror the sketch, and then we're going to revolve the sketch to create our part. So there is a mirror option under modify. And so, let's see here, where is mirror? We have symmetry, offset, move copy, and mirror. I knew it was there. So we can use the mirror tool. The big thing is we have to select everything that we would like to mirror. So what we can do is pick all of the objects that we would like to mirror and just walk our way around. And yes, can this be tedious? It sure can. Can you use a window? Absolutely, you can window around it. But we now selected everything that we would like to mirror. Now we need to pick a mirror line. The mirror line that we would like to pick is here. So it originally selected this object as our mirror line, that center line. Okay, that makes sense, but that's not what we need. So we have to deselect it. And typically holding the Shift key and selecting the object will deselect an object. So holding the Shift key on the keyboard and selecting it will deselect. And this time we're going to go ahead and mirror by picking, oh, it won't allow us to select this, it wants a center line. Alright, so let's take a step back and draw a construction center line to mirror with. So we'll just draw a line here, pick it, right mouse click, and make it a center line. Use the mirror tool select our objects again, and this time we can window around it, and what he did was left mouse click hold, window around the objects, select the mirror line, which is the construction line, and you can see that the shape of the object is now mirrored horizontally. It really does want that center line to be the mirror. And we can choose OK. And now we've got a shape, and we could theoretically remove the center line because the center line does not change the shape of the object at all. So now it's one solid object just by selecting or highlighting that center line and hitting the delete key to get rid of it. We'll finish the sketch and we'll revolve. And the axis of revolution, since we have two center lines here, it wants to know what the axis of revolution is. And that's our axis of revolution. So this is our object. It looks a lot different than what is actually being displayed, but we're going with the dimensions that they're providing us. So now we've got the wheel. Okay, so we've got the wheel. So the next step is once we have the wheel, we now can create either the shoulder bolt or we can create a pin to go through here, so that way we can revolve this object. And so creating a shoulder bolt is an assembly kind of thing. We can actually use a bolt and build a bolt under the assembly environment, but we can also just create another new component to make a bolt and physically develop our bolt ourselves. And so it wouldn't be too hard to do that. The big thing is we want to use the correct diameters and information. So what we have, or what we know, is that inside these 1-inch holes we have we're going to have some bushings, and those bushings will change the diameter. Let's see here, the inner diameter is going to be 5/8 of an inch. Well, theoretically, this wheel with a 1-inch diameter here, that's not going to work well if this is going to be a 5/8 hole. So again, we can go back to the wheel, go back to the sketch and edit the sketch. And remember, we questioned that when we were looking at this design, that this hole of being 1 inch seems to be large, but that's what they actually spec 3/4 of an inch. So, we could say we want to make this 0.75, and then this distance here, we can make this 1.0. And that's awful thin, so we might go 1.25. And so yes, we're changing the part a bit. However, what we're doing is we're going back and looking at the other components and saying, well, how does that all fit together, and is this the right design for that? So as an engineer, you don't necessarily want to question everything, but when things don't match up or the information that you're given is not consistent, you want to ask questions. And we'll finish the sketch, and that now updates the part with a better hole in that wheel. Alright, so looking at that, we can create the bushings. Those are easy to create, and we can then develop the shoulder bolt after the bushings, or a shoulder pin after the bushings. So we'll again create a new component. So we'll select new component, standard. The component that we're going to call is bushing. And what we're going to do is create a sketch. Makes no difference, but we're going to go ahead and create it on the YZ platform here. We'll look at it from the right side view. And the bushing, we're just going to make it really simple. It's going to be a couple of circles here. So it's going to be an inside circle with an outside circle, and we'll put some dimensions on it. And so the inside needs to be 3/4 of an inch, diameter. The outside needs to be 1 inch in diameter. Okay, and we'll finish the sketch and we'll extrude this to a thickness of a 1/2 inch. We just want to extrude the outer edge, and we want to extrude this, and our extrusion box is over here on the right hand side. The distance is going to be 0.50. Now it's telling me that the outer diameter is a 1/2 inch and the inner diameter is 5/8. Okay. Since we're designing our own pin, as opposed to using a standard socket head shoulder shoulder cap screw, more or less, we could go either direction. We could make this 5/8, and we can always come back and edit this also. So that's one of the things that we have the ability to do, and it's going to create it as a new body. And so we've got a new body under this feature. Body sketches, bushing. And so theoretically I should be able to move the bushing up above the wheel. However, the wheel, the bushing was created based on the wheel, so that's not good. So let's go ahead and we could change this. So one of the cool things is that we can change a body, which is what the bushing is, which is tied to the wheel, to a component. And so we could create this and edit this object and make it a component here. So what we did, we right mouse click on the bushing, and let's see here, there should be an option to change its feature capability to a component. And I might need to be out of the object before I can do this. I can create a new component, but I can change a component. So right now this bushing is activated. So let's go up and activate the base plate. If the base plate is activated, and I can right mouse on this, show hide, the bushing. Just looking to see here, I'm looking at how I can transfer this bushing to make it not part of the wheel. And so I may have to go in and edit this and recreate this outside of this wheel. Or I can save a copy as a possibility as another component. So there's different ways to work on this. We'll solve this problem in just a second. So the bushing is there. It is part of the wheel. We want to actually be part of the base plate to create this next object in the assembly. And what we want to do, to take and insert a shoulder bolt or any bolt, we go through the insert option, and we insert based on McMaster Carr. And so the McMaster Carr is a catalog of pretty much every type of fastener and component that you might need. So we go into the McMaster Carr, and theoretically you can buy directly from McMaster Carr. So this is part of the thinking of having their database associated with this. And so we can go to screws and bolts, or threaded rods, or spacers and standoffs, and there's quite a few different things that we could do with this. And again, this welding and brazing and pipe fittings and power transmissions and shaft information. And so all these components are items that you can purchase through McMaster Carr, but you can also bring them into Fusion 360. But in our case, we're going to be looking at screws and bolts. So we're going to be looking at a socket head, because that's what it indicated that it was a socket head shoulder screw. So we're going to do socket head. Now there's different types of socket heads. Socket head screws, ultra low profile, high profile, meaning the size of the head. We're just going to go with a standard socket head. And then the type. So there's different types, Torx, which is a torque configuration, because a typical socket head will have a Allen wrench configuration. And so alloy steel is fine, not a military specified or a left-hand screw. High temperature stainless steel is also common. Chrome plated, cleaned and bagged, corrosion resistance, titanium, brass, aluminum. So again, you can select the type of socket head that you might need. So we're just going to do an alloy steel, because those are usually the easiest. And ours is going to be partially threaded, hence the shoulder. This is considered the shoulder of the socket head. So it's partially threaded. Now, there is a long list of different socket heads. So now that we've selected the type of product, we can go to the thread sizer and start to work with this. So ultimately we need a 5/8 diameter shoulder. So let's see here. So it gives us thread pitch and length and threading. We want it partially threaded, socket head profiles, drive style, head diameter are choices, minimum thread length, coarse, fine, and extra fine. We learned about those. Head height, thread type, drive size, and I was just looking to see if there was anything with the shoulder distance. So ultimately, the overall length of this shoulder bolt is not provided. So knowing the distances here of a 1/2 inch thick for the plates, that's 1 inch. The wheel is at least 1 inch to 1.25 inches. So that's now 2.5, and we could do easily another 1/2 inch, if not more, for just the fastener, the nut component. So, we're looking at a 2 to 3 inch overall length. But as indicated, we have to pick our thread size first. And so our threads, looking at the way that the hex nut is, it says that it's a 1/2 inch 13, which is a unified national course. So here's a 1/2 inch 13 for threading. So now this is our 1/2 inch 13, and we've got a variety of different sizes. And so I'm thinking 3 inch may be the appropriate distance here, though I'm also thinking that it might be too long. So 2.5 inch might be the appropriate length here, because it's 1/2 plus 1, it'd be 2 plus 1/2. Okay, we can always update it and make it 2 3/4 if we need to, but we'll go 2.5. And we don't need a SolidWorks file. What we need is, let's see here. Well, we could bring in a SolidWorks file. That is appropriate. That would indicate or work for our design. Okay, so with this, we could download the SolidWorks, but the step file works the best for Fusion 360. Fusion does allow importation of SolidWorks files, but then it would have to go through an import process. So we're going to go ahead and download the step file, and we'll choose download. And there is our socket head cap screw. However, it looks like it's not rotated properly, so we can rotate the socket head cap screw appropriately, and we can accept it. Alright, so theoretically, that's what came in. It isn't really what we're looking for as a shoulder bolt, but that is what the specifications indicated as we set this up. So bottom line is we may have to go back and delete this, and we can't really edit this because as a step file we don't have all the data with the step file information. So we'd have to go in and delete this object and then either insert another one, or in our case we're going to go ahead and just design a pin to accomplish our task. So that will be in our third video, and so we'll design the pin and we'll take this and finish the assembly process. Have a great day. Okay, so we're working on fixing this wheel since we had deleted some of it and it just wasn't cooperating. So what I did is I took and deleted the half to the left and redrew it. And upon that, I did a bunch of the equals. So this side's equal, the left side's equal to the right side and so forth. But at this point now, we need to make it wider. So the space that we have available is 1.5 inches. And right now I've got it set at 3/4 of an inch. So we can adjust it as necessary. So ultimately, what we can do is we can make this dimension, which basically is the distance from here to the center point, half of whatever this value is. So I'm going to go ahead and double click on this. And right now it says that it's D69 divided by 2. And so D69 happens to be this dimension, the 0.75, and I can divide that by 2. And one of the cool things is that we can put in functions or equations to accomplish dimensioning inside Fusion. And so now whenever I change this dimension, so if we change this to 1.0, this now changes to 0.5 and it keeps everything centered. Well, this isn't centered. So now I can do the dimension from here to here and delete that and say that this dimension is going to be half of this dimension. So this divided by 2 will be that dimension. That didn't work out as well as I planned. So let's delete that and say this dimension divided by 2. And again, that didn't fully set that up. Should be 1/4 inch, but it didn't set up the positioning appropriately. And it could be, why isn't it that? That worked out okay as a function. This one did not work out as a function. This is 0.50. So now that works out okay, is this divided by 2. If we do, again, it's got to be a function of the width of the object. And then again, we can dimension the bottom, but the bottom looks pretty good at this point. So we're going to leave the bottom as is. We'll finish the sketch, and when we look at it, we can see that the base plate will turn that on so you can see all the pieces and parts. So you can see that things have changed a little bit here with this this wheel, and this wheel Oh, I didn't like that, whatever happened there. Let's close up our menus here. So this wheel is still constrained to the face of the plate, or should be constrained to the face of the plate. That's the joint that we put in here, and we can edit this joint and adjust it so it can be centered in the space. Okay, so the 0.35 I think is the centering distance at this point. When we look at the centering, we can see the ghosted image on the right and the left. It looks pretty clear. Okay, so that works out okay. Now we should, in essence, maybe go back and make this even wider. So it's only 1 inch wide. It might want to be 1.25 inches wide. But you get the idea. You know, we can go ahead and set this joint and now adjust that joint based on the size and how that's been modified. Alright, we'll insert the pin and see how the pin looks. So the joint of the pin, I want to select the base of the cylinder here. And that base of that cylinder is going to be located at the face of this hole. So when we look at the front view, you can see that the pin goes through. And theoretically, things look okay. The cylinder here should probably be a little bit longer, and then this threading should be a little bit shorter overall. So again, we can adjust that. We can go into the bolt, make that edit of this extrusion and make the extrusion another 1/4 inch longer. And that's not a problem. We just select the bolt to turn that component on. In the bolt, you'll notice that we have the history. And so the first extrude was the original cylinder, and we want to edit that feature. And right now it's 2 inches, so we can make that 2.5. So now you can see that the overall distance is appropriate. But now this is this is fine. We can actually set it at this point, and that way, if there's a threaded bolt, or excuse me, a threaded nut onto that object, it would basically solve the problem. And that's how this works. You can select the objects, make them active, and to activate the whole assembly, you select the top item and make that active. We can put the bushings in, and again, we want to rotate this to the appropriate side. So I'm going to pick this face and select again the appropriate side and pick this face, and that bushing will set. Now, that bushing is currently not in the right orientation. Okay, so that bushing, we can slide this bushing in by that 1/2 inch distance. So now that bushing sets inside the angle bracket. And so we can control, using the arrows, that position of that joint, which makes this much more powerful than the other software tools that we work with. So now you can see that the bushing is set. And the only other thing that we would do is create some bolts through the McMaster car insertion, the 1/2 inch diameter bolts to thread in, and we could drop in a nut also. And to do that, we'll just do the nut real quick. So we'll just insert a McMaster car component. We're going to do a nut. Theoretically, we would do a washer and then a nut, or a washer, a lock washer, and then a nut. But we could do a lock nut instead. We could do a flange nut. Flange nut would probably be better overall. But theoretically, we could do a lock nut because it could be a vibration. But we'll do a flange nut. 1/2 inch flange nut by 13. And let's see here, high strength serrated flange lock nuts. This is a medium strength, grade F. And again, there's different types of stainless steel. There's different grade levels. This happens to be a grade 8, which is an extremely high strength. This is a standard, grade 5. We select the part, or we can pick the information, and we would like to download it as a 3D step file. And it will appear, and we can locate it in a position that we can work with and accept it. And now, as we were doing before with the joint, is choose the joint, choose the face, and then I can choose the face of the bushing. Okay, so now we need to rotate this. So we want to change the way that the bushing faces. Let's cancel this and try this again. So let's do a joint. Okay, Z positive is there. I want to do this. I believe Z is negative there. So we can flip the position of this using the flip button at the bottom, and notice that the nut flips the position, and now the nut is set. So again, that solves the issue with the flange nut. The bushing is in place. And we've assembled the part. The only other things that we would do is put in 1/2 inch bolts to hold the 4 positions down and work from there. To explode this, we would then go into an animation mode and explode this. But I'm going to save this at this point, and call that it's an assembled. And then if we were to create the animation, we would go into the animation mode, and that would allow us to begin the idea of developing a storyboard in transform. Transformation is the component moving, so we would actually transform the components the same way that we would bring them out. So we'd want to do the bolt first. Actually, we'd want to do the nut first. So the nut would come off, and we can actually see what the components are in the base plate. So the lock nut would be our first item. We'd select that. We would transform it by selecting it and bringing it out. And we can control the distance here. Right now I just moved it 6.4 inches off of this piece. We probably need to move this a little bit farther. Why? Because the angle is going to have to move. Second thing that we would transform would be so we pick the move. And again, transforming things, we can again do a timeline. So I can say in 3 seconds I would like to move this object out, and then choose OK, and then in 6 seconds, right now it's at 3, We'd go to 6 seconds, and at 6 seconds we would transform the wheel and move the wheel straight up. And at the same time, we'd grab the bushing and slide the bushing out. And then at 10 seconds, we would move both of the plates, both of the angle plates out. We'll leave them slightly modified. But you can see what happens here is that it builds a step-by-step guide. Now we can go back and hit the play button. And we've got an exploded assembly. So using the animation and the transform tools and the timeline, we can control how the object is exploded. We save this because we want to save the animation. Okay. And then we would publish the animation. And so theoretically we could actually create a video that we could share with our friends with this. So publishing the animation, we can view it, and the idea is that the view, we can record the animation if we wanted to go through this process. So if we go back to 0, the view is not recording. Why are we not recording? Let's see here. Now the sketch that's in the wheel, I left that on. And then we can publish our current storyboard. And that would create it as a video export. Now, as an exploded assembly, we can take photographs and we can also create annotation callouts. And let's see here. And so then it would publish the video. So when we create drawings, when we choose the drawing option, we have the ability to create from a static design a part, or we can have it from an animation. And so if we start with the animation, we'll choose Storyboard 1, which is this. We're going to create a new one, and it's going to be a B-size sheet. And we'll choose OK. So what it's going to do is it's going to bring in the exploded view from the storyboard that we can then use to create a parts list and balloons and so forth. And so as we place this base view of the object, it's our exploded assembly, and we can shade it. Scale is going to be 1 to 5, so it's going to be pretty small. Thread edges are going to show up if we choose to, and so forth. And we'll choose OK. Alright, so it's a shaded out environment. we now have the ability to create tables. And so the table that we want to create is a parts list table, and then balloons. So we'll create a parts list, and parts list can reside in the lower corner here, which is an appropriate spot because it's not used all that often. And so we've got part 1, 2, 3, 4, 5. It then created the balloons automatically. We know that the bushing, that there are quantity 2, it thought that the bushing and the wheel are the same, and that was part of our design flaw that we did early on. And so we could, let's see here, if we edit leader text, I don't know if it will allow us to edit that. It will not allow us to edit this balloon. We can delete the balloon, but we can't edit the text because it's considering this as part of the wheel. So we could delete the balloon. Select objects to delete. And then I can add a balloon to the wheel. And then that's the wheel. And then 3, I could edit the table. And so that's where we have the ability to work a little bit to edit the bushing information. So we should be able to edit this and work from there. And we may not be able to until we fix this in the assembly where it pulled the information. But you get the idea. We create the animation comes into the drawing. We can then create the parts list and the balloons. We would then create a new drawing. So in essence, we'd want to create a new drawing sheet. So down here on the bottom left, we would hit the plus sign and we would create a new sheet. We would then bring in a new base view, and we would have to select whatever the model that we want to work with. And so we want to create, right now it's going to be the orientation of the assembly. But ultimately we want to create a new view of a model, and it's not allowing me to change my model view. So let's see here. Sheet settings, sheet 2. So in sheet 2, we want to bring in a new view. So we have to start with the base view. And it says place base view, but we actually want to change our reference and create a new reference from the model. And it's not allowing me to change that reference from that model view. There is a way that we can bring in the detail views, and so that's the storyboard, this is the model, and cancel, and we can always delete the sheet if we want to. The advantage of doing this is that the sheet allows us to I wonder if we do this, we want to create view. So the base plate, the reference is the base plate. No, we don't want the storyboard, we want to create this and the model. But I know that we can copy sheets from one design sheet to another. You can just copy the sheet name and then paste the sheet into this list to copy the sheets into position with the individual part details. When you're finished, you'd want to PDF export all the sheets. So I didn't want to make this video too long, but we got much longer than I expected. Have a great day, and we'll talk to you soon.